we're going to take equations that look like this and use these function tables to get a picture of what the graph of this function is going to look like. And I'll show you what I mean by that in the second example. But since we have a y and an x in our equation, and we have x's and y's in our ordered pairs, what we're going to end up with are ordered pairs that work for this equation. And we're going to figure out what ordered pairs, or at least some of the ordered pairs that are going to work for this equation. And then when we get those ordered pairs, we're going to see what that looks like, what kind of picture it gives us. And we're going to use this function table here to just organize our work. So let me ask this question first. Does this equation right here look familiar? Or at least an equation like this? Where have we seen equations like that? In our openers, right? In our openers, I've been giving you equations that have x's and y's in it. And what did I ask you to do? What have I been asking you to do for the last couple of weeks with us? Solve for y, right? Well, this is already written like that, where it's already solved for y. So this is like one of the answers to those openers, right? When we're doing this, first of all, the x values that we pick over here, these x values, it doesn't really matter what we pick. We can pick any x numbers we want, although we want to pick ones that are easy enough for us to work with, and we want to pick some that will fit on the graph. And we'll talk about how that works later. For now, I'm going to pick the x values that you're going to use. So as Aaron just suggested, what we're going to do here is we're going to rewrite this equation. We're going to take this equation, we're going to rewrite it, but instead of x, what are we going to put in there, in this box? We're going to put a 3 in there, because x is equal to 3. So we're going to write y equals 2, 3 plus 3. Why? Can't I just put 23?
No.
What does this mean? What does 2x mean? It means 2 times x, right? This does not look like 2 times 3. The simplest way to do that is put the 3 in parentheses. When we substitute the 3 in for the x, we'll just put that 3 in parentheses so that we can tell that we're multiplying still. And then what we need to do here is just figure out what 2 times 3 plus 3 is. So what is 2 times 3? What's 2 times 3 here? That's 6. I'm going to write it underneath. 6 plus 3, and that's going to be what? 9. So when x is 3, what does y equal? 9. So I'm going to put that in this box, because we got 9 for y. Now once we get that, what do I put in this box over here? In this column? Yeah, I'm going to write the ordered pair. Now be careful here. The ordered pair has to have a few things. I can't just put 3, 9, but what else do I need? I need a comma to separate them, and I need the parentheses around it. Without the parentheses, it's not an ordered pair. So I would like you to go ahead and try to do the 5, the 8, and the 9 on your own. Again, you at least need to show what I have circled here in red for your work to show us what you're putting in for x and what it looks like once you put it in there. Somebody want to help me with the 5? We're going to get y equals what? Diavian, go. Okay, and what is 2 times 5? So we get 10 plus 3, which is 13. All right, so then our y value is going to be 13, and what's our ordered pair going to be, Diavian? I think you meant 5, 13, right? Okay, Courtney, how about the 8? What do I put in this column here?
And the one y equals 2, this is 8 plus 3.
Okay, and Courtney, what is 2 times 8? All right, so we get 16 plus 3, which is 19. So what's our y value?
It's
19,
19.
and what's our ordered pair?
8 and 19, well, 8, well, parentheses, pair, and then 8, and then
Comma?
yeah, and then 19, and then
and then close parentheses. All right. Robbie, how about the 9?
2 times
Don't forget the y equals. That y equals is really important. So y equals,
2 times 9 plus 3,
and what is 2 times 9?
18,
And what is 18 plus 3?
21,
Okay, so our y value is,
9x,
y value is,
21,
okay, and then our ordered pair,
9x, 21.
9x.
No, 9 in the x place and 21 where the y is.
Okay, and what am I missing here?
Parentheses.
Yep, don't forget those parentheses. I said earlier we want to pick x numbers so that we can plot these points easily. What do you guys think about these y values that we got here? Would that be easy to plot those on a coordinate plane? You'd have to have a pretty big coordinate plane, right? The biggest one we've had so far that we've had to use in this class so far only went up to 10 on the y-axis. And this one goes, we would need it to go all the way up to 21. So if I saw something like this, I would probably try to choose numbers for x that are smaller. And if I choose numbers for x that are smaller, then I'll get numbers for y that are smaller. Because you can see, as the x numbers go up, the y numbers go up, and they actually go up even faster, right? So the bigger the x values are, the bigger the y values are even more. So when we're doing these function tables, if you have to pick the numbers, you want to pick numbers that are going to make not only your x number small, but your y number kind of small too, so that it's easy to graph. Okay, let's go ahead and do another one here. This is example 2. And I'll let you go ahead and just fill out the whole chart on your own. Okay, don't forget to put the equation right here in this box at the top. And then go ahead and plug in the values for the x and figure out what y is, and then write your ordered pairs. So when we plug -3 in for x, we have to be careful about our negatives here. Remember, the -2 in front of x is negative, so we get -2 times -3. And what's a negative times a negative? It's going to be a positive. So we get +6 plus 1, which is going to give us 7. So our y value is 7, and our ordered pair is going to be what? Anybody? -3, 7. All right. For the second one, again, you just have to make sure that you plug the -1 in the right place. And when we multiply a negative times a negative, we get a positive. So you should get a +3 for y, and the ordered pair is going to be -1, 3. We're going to multiply a negative times a positive. Remember, -2 times +1 is going to give us -2. That's going to give us a negative. And when we do a negative plus a positive, are we going to add or subtract? If you have a negative and a positive, do you add or subtract? When we have a negative and a positive, we subtract to get 1. And then since the negative number is bigger, the answer is going to be negative. So we get y equals -1, and we get the ordered pair 1, -1. And then the last one, we get a negative times a positive gives us a -6. Again, a negative and a positive we subtract to get 5. And since the negative number is bigger, it's going to be a -5. So our y is -5, and we get an ordered pair 3, -5. Does anybody have any questions about this? When we plot these points in the coordinate plane, I think we're going to see a pattern. I want one person, just help me with all 4 of them real quick. Claire, go ahead. -3, 7, what do I do?
Go left 3 and up 7.
Okay, and I think we're going to get right about there. So that's the first one. That's -3, 7. How about -1, 3?
Left 1 and then up 3.
Left 1 and up 3, okay.
And then right 1, down 1.
Okay,
And then right 3, down 5.
okay. What do you guys notice about all 4 of these points?
Oh my God.
Yeah, they're all in a straight line, aren't they? And it actually doesn't matter what number we pick for x. We pick -3, -1, 1, and 5. But it doesn't matter what number we pick for x. What the ordered pair that we end up with is going to be in line with these. So we could draw a line through those, and we would end up getting every possible point that's going to work for this equation. So we end up with something that we can draw a line through. And the interesting thing here is we get ordered pairs that we didn't even solve for. If you look at this here, can anybody tell me what the coordinates of that point are? 2, -3, right? Well, in this equation here, let's just do this in our heads. What happens if we put 2 in here for x? What's -2 times 2? -4, right? And what's -4 plus 1? -3. Isn't that the ordered pair we have here? We could do that again right here if we wanted, and I'm not going to keep doing this over and over again, but we get an ordered pair here, -4, 9. And this ordered pair is also going to work for this equation. So every ordered pair along this line here is going to work in this equation. Kind of cool, isn't it? It's going to turn out that every time we have an equation that looks like this, like the ones we've had in our openers, those equations are going to give us a picture of a line. And we're going to spend some time over the next couple of weeks talking about what those lines are going to look like, and we're going to look for shortcuts to figure out what the line looks like rather than using these function tables. All right. Again, as you're doing the work here, check your answers with mine and make sure you're getting the same thing. If you have any questions, let me know. So in this example, the x is in a different place. Actually, it's in the wrong order, right? Because we want the constant term last. But even if it's written like this, we can still fill out the function table just like before. So go ahead and fill out your function table while I do mine, and you can check your answers as you go.